The last section on significance testing talks about testing variance and standard deviation claims. If you think back to the confidence intervals, what we had talked about with confidence intervals is that we can't use a z or a t, but we have to use the chi-squared. So in this case, if you flip to your chi-squared chart, well, the first thing we're looking at here is a right-tailed test. Don't forget, our chi-squared is a skewed curve, and we're going right-tailed, which means we're going to cut the right-hand side off, and all 5% is going to be on that side. If we talk about left-tailed, it's going to be on the left. In this case, my entire significance level, 10%, will be on that side, or 0.1. And if I do two-tailed, just like before, I'm going to cut a little bit off both sides. In this particular case, since it's 1%, it's going to end up being 0.005 on both sides. Now do keep in mind, when I go through and I look at my chi-squared, the number given at the top talks about the area to the right. So the chi-squared is a little bit different. So in this particular case, in the very first one, we're talking about a right-tailed test. My n value is 16, so I go on my degrees of freedom of 15. I know I'm doing a 5% significance, so I'm going to come to this column. And if I come across, I'm going to find 24.996 to be my test statistic. If I come back to the left-tailed test, well, now I'm going 10%. If 10% is on the left, it means there must be 0.90 on the right. So I come to this column. My degrees of freedom in this case is 10. So I come across, and the magic number for me is 4.865 for my critical value. In the two-tailed test, I'm going to have to find two critical values, one for this side and one for this side. Well, if I'm doing 0.005 on the left, that means I must be 0.995 on the right. So I come down, degrees of freedom 22. So there's my left-hand test statistic, and my right hand. So then what's the formula for this? Well, if we're going to find our test statistic and compare it against the critical values we just found in the last section, last slide, first thing I'm going to do is I'm going to find my chi-squared. And this formula is the same formula that we had for confidence intervals. That's not changing a whole lot. And this is going to be what we refer to as my test statistic, just like we have recently with the mean and the proportion. This is the value that we're going to check against our critical value. Let's look at a few examples. In our first example, the instructor wants to look at the variation of scores for her students against the whole population. She has a sample of 23 students, and the standard variance she finds is 198 for her 23 students, and she wants to test it against the 225 that's accepted for the population. So the first thing we do is we go ahead and set up our null and alternative hypothesis. Well, my null hypothesis, remember, is always going to be my equal sign. And the question is, what's my alternative? Well, in this case, she's claiming, she believes that it's less than. So she believes that the variance is less than 225, which means this is going to be a one-sided left-hand test, because anything to the far left-hand side will support this idea. My degrees of freedom in this case is n minus 1, so 22. The 0.05 all to the left-hand side. So when I go look at my chart, I'm looking up 0.95 for 22 degrees of freedom, and I'm going to find a critical value of 12.338. And now I'm going to find my test statistic. When I go to find my test statistic, I'm going to go ahead and plug this thing in, and I end up with 23 minus 1 times s squared, which in this case I have 198, all that divided by the accepted population variance, which is the 225. This is going to give me a test statistic of 19.36. So then in this situation, the 19.36 actually falls in this non-critical region, which means this data does not support the instructor's claim. The 198 is lower than 225, we can agree on that, but it's not significantly lower. Let's look at another example. The second example, now we're looking at standard deviation against standard variance. And the hospital administrator is looking at the idea that she or he believes that it's greater than 8. So when I go ahead and I look at my sample of 15 that has a standard deviation of 11.2, the question being asked by the administrator is my standard deviation greater than 8? Well, this is going to be one-sided again because we have a greater than or less than symbol. But in this particular case, because it's a greater than symbol, it's going to be a right-tailed test. In this case, we're looking at 5% significance, so all my 5% is on the right-hand side. I'm looking at 14 degrees of freedom, so I end up with a critical value of 23.685. And this is the number we're going to check. So I get my test statistic. I plug in my n, which is 15, subtract my 1, multiply by, in this case, I'm given a deviation, so I have to square it. And I'm going to get a test statistic of 27.44. That 27.4 is past my critical value. It's in my rejection region. Since it's in my rejection region, I reject the null hypothesis. So in this particular case, the data supports the administrator's belief that the greater than 8 people use outpatient surgery.